Morning. Thanks for being here. Can you guys hear me okay? Great, cool. Oh, sleepy Xander. Oh. Okay. Thanks for joining me. We're gonna kind of pick up where we left off last week. So as far as like where we are in terms of where the nodes I've assigned versus what we've done in these sessions. So last week I assigned chapters 37, 20, well, I don't even know. God, who knows? 37, we had finished 35, 37, and 25. So we're doing, what are we doing? We're gonna finish, today we're gonna finish, there's one little baby section of 35 I wanted to finish, and we're gonna go into 25. And then we'll slowly start to catch up this week. So if you wanna just pick up where you left off, that will be perfect. All right, let's do it. Okay, so this is like one little baby last section of 35 that I kind of accidentally left out, I think. I thought we had done it, but we had not. So I just want to make sure that we just hit on these few little topics from the end of 35. So that's going to start with altruism. And altruism is basically the opposite of doing something for the purpose of survival. But instead, it's kind of like a all-for-one situation where it's a behavior that reduces the animal's own personal fitness in order to increase the chances of survival of one of their own family members or close relatives. And I wrote friends and family because it makes the most sense to me, but this could be the colony or their small pack or tribe or that close-knit community that they're living in. It's more than just being a good parent, though. So that's different because obviously a parent knows that by saving or protecting their offspring, they're directly saving and protecting their own genes. They know it's their genes, so that does increase their own personal fitness. This is more than that. This is, I'm not positive those are my genes, but I'm in it for you, and this can best be represented with bees. Bees are very much all for one, and the one is the queen. And kind of the idea behind this is that a species knows that their genes have a close relation to, you know, the whoever it may be that they're trying to protect, the queen or the king or a certain few members that are, you know, kind of supremely selected within their group as having the best chance of survival or best chance for fitness moving forward when passing on their genes. So let's see, how do we write that? So it's a little bit I don't want to say unintelligent because all animals have behaviors for a reason that can help their selection. But in a sense, it's the idea that, you know, like if we're taking the bees for example, still, it's the idea that, well, I'm a bee and the queen is a bee, so if I save her, then I'm saving all bees. Come on. The relationship between, you know, one member of the group to the selected member of the group, so to speak, is called kin selection. And overall, when all of the members of the group decide to protect that one or a few members, it's called inclusive fitness. So that's the last little bit of 35. And again, all of these chapters kind of blend together as far as ecology goes, and we jump around a bunch. But the next area we're going to go to is 25. And I'm only going to hang out there for today, and that's it. Anyone enjoying a delicious breakfast this morning? Did anyone do anything fun over the weekend? No, not one fun thing. All right. Chapter 25 then. Let's make that the most fun thing that's happened. Here we go, thermoregulation. So you probably watched the Bozeman on this last week, and thermoregulation is pretty intuitive. It's just the idea that, because we have cells and enzymes and proteins in our body that need to maintain a very specific temperature in order to function, the animal is in charge, or, autonomically in charge, so they're not really controlling it, but the body basically controls a temperature, excuse me, in order to maintain the homeostasis, if you will, of the rest of their mechanisms. So it's the internal temperature management. And thermoregulation can kind of be broken up into two different types of animals. So we have, oopsie daisy, how do I put that over here? This over here. So we have endotherms and ectotherms. Where endotherms use metabolism to produce heat. And ectotherms absorb heat from their environment. And obviously there's animals that do these exclusively. And then a lot of animals that do a little combo of both. So most common example of an endotherm, anybody?
Wouldn't just any warm-blooded creatures be endotherms?
Absolutely. If you're warm-blooded and you move around, you probably are doing some endotherm stuff. But some animals that are specifically endotherms because they can't necessarily absorb heat from their environment. Think of like an animal that lives where it is constantly cool.
Maybe snakes.
Okay, a snake would be a good example. Actually, it's a good example of a combo because, a snake, when they move around, obviously they produce heat, and if they're close to the ground all the time, it's definitely going to be cooler. But then a snake can go up on a rock that's nice and warm and sunny and absorb heat that way. But I'm thinking specifically of fish and animals that live in the sea, because the water is typically colder than what their internal temperature should be. And so they depend mainly on moving around and swimming around to produce heat. Your ectotherms, think of animals that are super sluggy, don't move around a lot, and could live in a colder or a really hot environment where they really need to depend on where they're going to sleep or hang out in order to transfer that heat.
against like reptiles, right?
Yeah. So I'm thinking like a slow tortoise in the desert, somebody like that. Ooh, but do I have to draw a turtle? Give me another 20 seconds or so on this page, and then I gotta switch over. Anyone watch that iHeart Radio concert last night? It was good. Okay, just staying on the topic of thermoregulation a little bit longer, mostly for my own fun, because we get to talk about a little bit of chemistry here. And the chemistry of thermoregulation, or the thermodynamics. So just speaking on terms of just vocabulary when we're talking about how heat is transferred through animals. First concept is conduction. And conduction means just the transfer of heat. So you may remember in chemistry, when we're talking about good conductors, that's all your metals are usually good conductors. Even better are those metalloids. So we're on the rightish side of the periodic table. That means they're really good at passing heat. And when something passes heat, it always passes it from high temperature to low temperature. So something that is warm is going to transfer its heat to something that is cool. And if you're thinking like, well, how does something get hot in the first place? Didn't something have to transfer its energy that way? Yes, but it's in a different form. It's in the form of excitation of electrons. And oh man, I could go on and on about electrons, but it's not the same as transferring heat. It's transferring energy first, and then when energy builds up enough, it creates heat, and then heat gets passed or conducted into something else. Next vocab term is convection. Convection is the transfer of heat by use of air movement. I always think of an oven when I think of convection, because if you have a convection oven, or kind of a fancier oven, it probably uses hot air circulating in the oven to heat whatever is inside, rather than just, if you have an electric oven, it's just a big metal bar at the bottom that gets really, really hot. Or like if you have a gas oven, it's just a flame underneath that kind of like pushes air up into the oven. But it's not the same as convection, where there's air circulating all around, and that's what like makes the best baked goods or something, because it's global heat throughout the oven in the same temperature, rather than just coming from the bottom or coming from the top. But convection, as far as heating or cooling an animal, can be as simple as, a bird is feeling a little warm sitting on the branch, so he goes for a fly, a little soar through the breeze, and that blowing of the air, cool air around him, is going to cool him down. Next one is radiation. Not necessarily radiation that we would think of in terms of like a cancer treatment or scary rays from a power plant. This is radiation that comes from some other heat source, like maybe the sun. I just love when, any type of definition or any topic or conversation involves electromagnetic waves, because it sounds like it's this like crazy thing, super intense, but electromagnetic is just a fancy word for, anyone know? Oops, I already started writing it. For light. So that should be pretty obvious. An animal wants to get warm, go lay out in the sun. Want to cool down? Get out of the sun. Last one, evaporation. We obviously know what evaporation is, but in terms of regulating body temperature, it's the loss of heat by molecules within the animal's body passing through the phase from liquid to gas. So we know that if we put a pot of water on the stove and we boil it at the surface, the water is releasing that heat in the form of water vapor as it floats away. Okie dokie, so that's all of the ways that heat can be transferred in and out of an animal's body. But in terms of how can they keep the heat in, ooh, what happened to my circle? Let's try again. Not terrible. All right, we've got 5 different ways that animals can keep heat. Okay, the first one is metabolic heat production. Science vocab is so good at making things sound complicated, but if you just break everything down, it's exactly, the title is exactly what it's saying if you just break it down. So metabolic, meta just means to move. You're just moving around. That's it. Heat production, you're making heat anytime you move around. So one way an animal can do that is move around. Swim, fly, walk, run. In the book, they also give the example of shivering in order to create heat. And you would think like, for us anyway, for humans, shivering is kind of a response to it being cold, and it's not necessarily like a behavior, it's more of a response. It's not something that we normally do on purpose. At least I don't. But some animals do it on purpose in order to increase their metabolism and create heat, which this was kind of fascinating to read about, for me anyway, because I can remember when I was a kid, I had an uncle that I would go back home to New York to, spend winters, some time vacationing there or whatever. And you know, I would be freezing because I'm a California girl and I'm here in the snow, and I'd be like shivering and shaking, and my uncle would be like, stop shaking. He's like, that's the worst way to stay warm. Like, just hold still and take a deep breath, and then you'll be warmer. And like, I did that my whole life. I was always like, okay, don't shiver because that's not going to help. Just got to relax, and then you'll get warmer. But then I'm reading this last week, and I'm like, wait a second, shivering does help. I knew it. I knew it the whole time. Second one is insulation. Insulation, just like we insulate our houses to keep heat in, cold out, animals have the same thing. They can be in the form of fur, feathers, blubber. And when we think of blubber, we think of like thick layers of fat, which is true, that's what it is. But just don't confuse it with just being, you know, just regular fat, because some animals can just have like a layer of fat, but that doesn't necessarily always keep you warmer. Blubber is like an exception to fat. It is like densely packed brown fat that kind of is almost harder in consistency or texture than normal fat. So it definitely has a better, what is the word? It's less good? No, it's better at not conducting heat. What is that? It's not a conductor. It basically creates a barrier between the outside. It's confusing, I'm sorry. Next one is circulatory adaptations. So circulatory adaptations, there we go, adaptations are kind of cool. It's basically like the vasoconstriction or vasodilation, which means the increasing in width or decrease, or diameter, I should say, increase or decrease in the diameter of your vessels of your body in order to restrict or constrict or increase the flow of blood throughout the body. So they gave examples of dolphins and geese that would do this to their extremities. Again, especially the ones that are, the parts that are in the water where it's sometimes colder. This is me trying to draw a dolphin, guys. Oh boy. Oh boy. Okay, well, that's something. And basically, as warm blood moves out to the limbs, let's make that pink so we can see. Uh-oh, now I lost his tail. Oh boy, things are going south. Then the cool blood is moving back into the center of the body. And that's called countercurrent heat exchange. Okay, the next one is evaporative cooling. So we just talked about evaporation in terms of one of the chemical mechanisms for exchanging heat. So evaporative cooling, then, you can imagine, are all the different ways animals behave to get water to move from that liquid to the gas stage. So panting, sweating, elephants spray water all over themselves. And one of the ones that I thought was kind of interesting but super gross is spreading saliva all over themselves. Weird. And also, I mean, you know, it didn't really give any examples of animals that do that, but I'm wondering, like, is that why, you know, dogs or cats will, you know, lick themselves all over the place? But I thought that was for bathing purposes, but maybe it also cools them down. But I just couldn't really think off the top of my head of any other animals that are licking themselves. Gross. Okay, last one is behavioral responses. Behavioral responses to regulating thermodynamics in the body is usually a last resort. Like, my body is not doing it on its own with these other mechanisms, so I need to do something. I need to act in some way to either make myself warm or cool myself down. So again, these are pretty intuitive, but you're just going to go to a temperature that is more optimal. And this can be in the form of migration, or finding a warm rock, or if you're a human, just wear some clothes. Alrighty. So that is all we're doing for chapter 25. That was 25.1 through 25.3. So now we're at least caught up with what we were sort of supposed to do last week. I kind of reassigned some of the same notes from last week because I couldn't remember. I think I forgot some of them. So anyway, the next place we're going to is 37, and we'll start that tomorrow. Basically, so tomorrow we'll do some notes, Wednesday we'll do some notes, and then Thursday we're just gonna kind of do like a study guide. Instead of straight up notes, we'll make ourselves a little study guide for ecology. And then we're going to try to wrap up this objective pretty fast, again, just so that we can focus on getting to the AP soon when we get back from spring break. I also got a couple messages from people saying that I didn't post the breakfast at Tiffany's from last Thursday, so I'll find that. I don't know why that was. And then I also got a message saying that last Wednesday's was only 3 minutes long, like somehow it didn't record. And I looked and that's true. It's only 3 minutes. I don't know why the Zoom session didn't record. So I've been watching it this time to make sure that it has been recording the whole time. Looks like it has. So hopefully we won't have any issues. And the one from last Thursday was fine too. So that'll be posted as well. Again, this is kind of a moot point for you guys since you guys always come to this. So you already get them live. So you don't probably need to go access those. But in case you're chatting with other people and they're like, how do I get the notes? They should be up on Haiku now, with the exception of last Wednesday, which is only 3 minutes, which apparently was just a picture of my kitchen and that's it, no notes. So we'll continue on the rest of this week. It's like, just take it super mellow. Let's just like have fun with some animals. You know, we'll do one more little Patrice thing. We'll probably end the week with an essay question, very similar to how we did it 2 weeks ago. And then we'll just call it a wrap on ecology, since we know we're not going to be tested on that in the AP. And then we'll take a nice week off and we will dive into reviewing for that when we get back. I'm just looking that there's a couple things that popped up in the chat here really quick. Wadia said hello. Oh my gosh, Wadia, good morning. Welcome to Breakfast at Tiffany's. Thanks for coming. Oh, yep, you said any lizards. Good, good, good. Okay, Franklin, are we going to go over chapter 36 notes? Also, yes, we will. So yeah, I'm just jumping around. I'm going to go 37 and then 36, Franklin. So I know it's kind of all over the board, but just trying to stay with the flow of how the con was and how the HHMI biointeractives were, which again, we're a little bit behind, so it doesn't really matter, but just trying to stick with the flow that was laid out for us. Cool. Any other questions, guys? Oh, yeah, Xander.
Yeah. What was the Patrice Padlet do again? Is it when the next Padlet comes out? Is that what it was?
Yeah, basically, I'll give you tons of reminders before I erase the one from before. But I would say, you know, try to get it done by maybe tomorrow night, Tuesday night, because usually on Wednesdays when I turn it over to the next one, but you probably would have time Wednesday morning for finishing touches and stuff like that. If you haven't done it or you're still working on it, definitely go check out the Padlet before you start, or, you know, whatever, just to get some ideas, because some people came up with some really creative stuff. They're looking great. So yeah, take your time on it. And if you need more time, just let me know, because even if I pull down that Padlet, but you needed more time, like you can submit it to me separately. Cool. All right, you guys, I hope to see you tomorrow morning. Look for a normal AP Bio email from me later this morning with a whole week of tasks. Nothing crazy though. Alrighty, have a great week. See you tomorrow.